Good morning, one and all. Today, here we are with a new session and with a new topic. Introducing myself, Aparna.A.H, and my companions.
Archana Sudevan.
Bodhi.S, Dharman.
Okay, Archana, Bodhi, can you hear me?
Yes, Aparna, we can
Yes,
hear
Aparna.
Okay, have you ever wondered how you are able to hear me? Today, we are going to discuss about the reason. And in our class, we will find the reasons why you are able to hear me.
Okay, so first of all, let us introduce the components which are essential for hearing a sound. We can see that, suppose, see my vocal cord. It is a sound producing object. So from this vocal cord, the sound waves will be traveling through a medium and it will be reaching you through your ear. So here we have seen the three essential components, which is a source of sound, then second one is a medium, and third one, the hearing organ, which are the essential components required for experiencing a sound. So now, have you ever thought about how the sound is being produced or being traveled? Aparna, can
Yes. Then now you are speaking about the propagation of sound. Means sound travels from Archana to me through a medium, and the propagation of sounds actually needs a medium.
Yes. So medium here I have spoken and how it has reached. Here which medium has been utilized for the propagation? Bodhi, can you tell?
I think it's air.
Yes, exactly air. Then, is there any other medium?
Of course, there are other mediums too. Like, have you ever wondered about sound traveling through solids? Archana,
No.
have you wondered how sound travel through a solid?
No, I haven't. Can you just explain, Aparna?
Yes, Archana, we all have experienced this. When we lay down on our desk and just knock on the desk, are we able to hear the sound?
Yes, we can hear the
Yes,
sound.
Aparna.
Yes, this is because sound travels through solids. Desk is something which is solid and we are able to hear sound from that. So, sound can travel through solids. Okay, now can we get another medium in which sound travels?
I think liquids.
Yes, Bodhi, is it?
Yes, Aparna. The medium of sound can be solid, liquids, and gases too.
Yes,
Okay.
exactly.
Now, can you give us an example for sound wave traveling in liquids, Archana?
Yes, suppose if we are taking a utensil and when we are immersing it inside a bucket full of water. Okay, and then I have took a spoon and now I'm just tapping the utensil which is being immersed in the bucket with that spoon, then we can hear the sound. So from this we can infer that sound travels through liquids too.
Okay, now we have seen that sound travels through solid, liquid, and gas. Now I have a doubt. How is the sound produced?
Yes, sound production. For that, I have an idea. We can do an exercise through which we get the answer how the sound is being produced. So we can just sit straight. Okay, just sit straight. Okay, ready? Okay. Now take your four fingers. Take your four fingers and then close your ears. Okay. Now what you need to do is that you need to murmur yourself. Okay. Yes. So what have you heard, Bodhi, from that?
I have heard the sound. I think it is the vibrations, like some.
Yes,
Yes,
exactly.
exactly.
The
Also,
vibration.
vibrations are something which produce sound. So sound is an end product of vibrations.
Vibration.
Okay. And sound travels as a longitudinal wave. That is, it travels in the form of a wave through a medium, and sound is a longitudinal wave. Okay. Now we can see the images of a sound as a longitudinal wave.
Okay. So here I am going to present. You may just say whether it is being seen or not. Can you see, Aparna?
Yes, Archana, we can see
Yes,
it.
Archana.
So now I have put this slide. So far we were discussing about what sound wave. Then we have seen how the sound waves are being propagated, the three essential components. Then we have seen the medium of sound, which can be either solid, liquid, or gas. Then how sound is being produced. Just we have seen it is through the vibrations. And lastly, we have seen that sound is a longitudinal wave. Aparna, can you just explain this figure of longitudinal wave?
Sure, Archana. We have already told that sound is a longitudinal wave. In this figure, you can see the wave that in some places it is closely arranged and in some places it is somewhat loose. This we can call it as compressions and rarefactions. The closely arranged portion is the compression, and something which is loosely arranged portion, that is rarefaction. Compressions are there when air particles come closer. The vibrating particles come closer. We call it as a compression. And when air particles are further in their mean position, we call it as rarefaction. So in a wave, we can see both compressions and rarefactions. Okay. Okay. Now, Archana, can we discuss about some of the characteristics of the sound wave?
Okay, of course, we can discuss about some of the characteristics. So for that, just pin on my video so that you can clearly see myself. Okay. So, you all might be loving to hear the music, right?
Yes, of course,
Yes.
Archana.
So here we are mainly going to discuss main two characteristics. The first characteristic I'll be just demonstrating to you, and thereby I'll be giving the waveform of that particular characteristic. So you need to just infer and observe what are the summary or the conclusions from that. Okay, so are you ready?
Okay, ready, Archana.
Yes, Archana.
So first of all, I'm having two murmurs. Okay, I'll be presenting two murmurs. You need to focus upon that. Okay, first murmur. This is the first murmur. Okay, and for that, I'm just drawing the wave for first murmur, which is like this. Okay. Now, second murmur. Have you heard?
Yes.
Yes, Archana.
Yes. Okay. So for that, the sound wave is propagating like this. Okay. Is it clear? Now, the question
Yes.
for both. What is the difference that you have seen in these two waves? The first one and the second one.
I think in the first one, the number of vibrations are less. And
Yes,
in the second case, the number of vibrations are more than when compared to the first one.
yes, exactly. Then Aparna, if the number of vibrations are less, then what about the frequency?
when the number of vibrations are less, the frequency will be low, and when the number of vibrations increases, the frequency also increases.
Yes. So this is exactly the first characteristic, which is termed as pitch, and it could be defined as the sharpness of the sound. So if a voice or the sound is said to be low pitch, it will be having a low frequency wave, whereas if it is of high pitch, then it will be having a high frequency wave. So the first characteristic is what? Pitch. Now, coming to the second characteristic. Okay, I'll be calling Aparna for 2 times in 2 different ways. First of all, Aparna. Okay, and for that, I have the corresponding wave. This. Now, I have increased my tone and sound, and I'll be calling Aparna. Aparna!
Yes.
Some difference is there, right? So
Yes.
now the waves seem to be like this. Bodhi, what is the difference you see here?
Yeah, the height of the wave in the first case was low, but
Yes.
in the second case, the height of the wave was increased.
That means the height, there is a difference. This particular height of a wave, sound wave, is known as amplitude. Okay, it is called as amplitude. Then, what might be the relation between amplitude, frequency, and loudness?
As the intensity of the sound increases, the amplitude increases and hence the loudness. In the first case, the sound was low and there the amplitude is less, hence the intensity is less and so is the loudness. In the second case, the amplitude is high, so the intensity is also high and hence the loudness. We can hear it in a more volume. This is the relation between intensity, amplitude and the loudness of the sound. Intensity increases, amplitude increases and loudness increases. Intensity decreases, amplitude also decreases and loudness, the sound will be much softer. Okay. Now you can see other exactly the images or the waves that is propagating in this. This is the first one, pitch. In the lower pitch, we can see less number of vibrations, and when it comes to a higher pitch, we can see the number of vibrations has increased. That is the case with pitch. And next one is loudness. When okay, you can see 2 different images. First one is a softer sound and second one is a louder sound. For a softer sound, the amplitude of the wave is small, and for a louder sound, the amplitude of the wave is higher. Okay. Okay, now I think we can go to an application in which we can clearly identify the pitch and loudness. For that, I will present to you an application. Okay, you can just demonstrate with it within your phone. You have to just install it. Okay, now I will share and show you the application. Can you see my screen?
Yes, Aparna, we can see.
Yes, Aparna.
Yes. This application is called multi-wave sound generator. Here we can see different frequencies, phase and amplitude. We can set the frequency and amplitude by our own way. You can see the add button over there. If we click the add button, you can set a frequency and an amplitude. So here in different cases, we can play the amplitude of different cases. Due to phone, this is not audible. Anyway, you can apply this and play it by yourself, and you can identify the difference between the different frequency sound and the different amplitude sound. You will be clearly able to distinguish between these differences, and you can clearly understand what is actually the frequency and amplitude changes. Okay. Now are you familiar? You can also install it in your phone and get more ideas about this pitch, loudness, frequency, and amplitude. Okay. Now we will move on to some of the applications of these sound waves. Here comes the first image.
Okay, I will be explaining some applications. First of all, let's observe the images. Aparna, can you identify this and explain the principle behind it?
Yes, Bodhi, this is a very familiar image and this is the stethoscope. We all seen this image or this object when we go to doctors for our checkup. And this is stethoscope and this is an application of sound wave, that is the multiple reflection of sound wave. Here the sound inside this instrument, the sound wave is reflected a many number of times and hence the doctors are able to hear our heartbeat and they can detect what is the problem with the heartbeat. So this is an instrument which make use of multiple reflections of sound. Okay.
Aparna, what you have identified from this picture, Archana?
Yes, this is a famous whispering gallery, Bodhi, and a major principle behind this construction is the acoustics of the building. Here, also as already Aparna told, the multiple reflection. That means if a person whispers from any of the sides inside this door, it will be heard as a louder sound. Okay, the main principle behind it is the multiple reflection.
Yes, these examples are coming under multiple reflection.
Okay, now we are going to another image. Archana, can you identify what is this image?
It depicts the ECG.
Yes, exactly.
Yes. So I think the ECG machine is actually using the ultrasonics, which is how the frequency greater than 20 hertz. And this is one of the applications of ultrasonic sound waves.
Okay. Now, oh, here is the second image. What is this, Bodhi?
I think it is sonar.
Yes. So what is this used for?
It can be used to measure the depth of the ocean, then to measure direction, distance, and speed of the object under the water.
Okay, now we have seen two images. That is, the first one is ECG and second one is sonar. As ultrasonics, that is, the ultrasonic sound waves are used for these two purposes.
Bodhi, what does the image depict?
Here we can see that seismic waves which have caused earthquakes.
Yes,
Yes.
seismic waves. Yes. So now coming to the seismic waves, can you just give a brief idea about seismic waves, Aparna?
Yes, different type of seismic waves causes what? Earthquake. We all are familiar with the earthquake. Seismic waves are something which causes earthquake. That is the movement of plates inside the earth. So they move. At the time of this movement, they produce infrasonic sounds, which has been detected by animals. We all heard about the superstitious beliefs that when something is going to happen in our nature, animals make a sound. This is not superstition, but it is science. That is, they all are able to detect the infrasonic sounds that is produced by the seismic waves. So they will be able to detect the sound and they will be aware of that something unnecessary or unusual is going to happen. So seismic wave is an application of this infrasonic sounds. Okay, now these are the applications of sound waves.
Okay, so
Okay,
here
Aparna.
we are coming to an end of the session and we have discussed primarily about the sound wave, its propagation and how it is being produced, the various characteristics, and for that we have also introduced an application. Then we have seen finally about the applications involving the ultrasonics, infrasonics as well as multiple reflection. So hope you all have got an idea about the topic sound waves. So here we, the group, is signing off. Myself, Archana Sudevan.
I'm Aparna.
I'm Bodhi.
Thank you. Bye.
Thank you.
Thank you.